Hey everyone! If you've ever touched JavaScript, the idea of a promise is probably second nature. Well, today we're going to dive into Go's very own version of that powerful pattern. And the best part? It's totally idiomatic. You don't need a single framework to use it. Let's get into it.
Oh yeah, we've all been there. It's the classic problem, right? You've got a function. It works just fine. It's synchronous, it's reliable, but now you need to make it concurrent. You need to run it alongside a couple of other things to speed up a page load. The very last thing you want to do is go back to the code that calls it and make it deal with channels and wait groups and all that complexity. That stuff should be hidden away.
And that right there is where the future pattern shines. It's basically Go's answer to the JavaScript promise. But the real beauty here is its simplicity. In JavaScript, promises are all tied into a bigger async framework. In Go, the future pattern is built from the ground up with the language's core tools, first-class functions and goroutines. No dependencies, nothing to import, just pure, beautiful, idiomatic Go.
So what is this pattern really? At its heart, it's all about a powerful separation of concerns. You completely separate the definition of what needs to happen from the actual execution. You say, here's what to do on success, and here's what to do on failure, and then you just kick it off. You fire and forget, and you trust the pattern to handle the details.
To make this super concrete, let's use a simple analogy that works perfectly here. A vending machine. Seriously, this is the best mental model for how this whole thing works.
Think about it. When you use a vending machine, you're basically using the future pattern. Number 1, you define success. The snack drops, you grab it, you're happy. Number 2, you define failure. The little spiral thingy doesn't turn, the snack gets stuck, and you know you're going to have to shake the machine or find a phone number. And number 3, you execute. You put your money in, you press the button, and then you walk away. You don't stand there micromanaging the gears. You just trust it's going to work. That is the very essence of fire and forget. All right, let's pop the hood and see how we actually build this thing in Go. It all comes down to a really cool concept, treating behaviors, basically functions, as types themselves. And here it is, the entire blueprint on one slide. We've got our main future object, which we're calling MaybeString, and it holds 3 fields, but they're not data. They're function types. There's a SuccessFunc for what to do with the string, a FailFunc for what to do with an error, and the ExecuteStringFunc, which is the actual job that needs to get done. We're passing around behaviors, not just values. And this is the payoff for that architecture. You get this incredibly clean, elegant, chainable API. It just reads like plain English, doesn't it? On success, do this. On failure, do that. Okay, now execute the operation. It's one of those amazing moments in programming where the code itself is as clear as a well-written sentence. But hang on a second. You might have spotted something a little weird. That ExecuteStringFunc, it doesn't take any arguments. So how in the world do we get data into our async operation? Well, this leads us to the real magic trick of the pattern. This seems like a pretty big limitation, doesn't it? I mean, if your operation needs a user ID or a database handle or something, how are you supposed to get it in there? The answer lies in one of Go's most powerful and sometimes overlooked features. The answer is closures. What we do is we wrap our logic inside an anonymous function. Now, here's the key. Everything outside that inner function runs synchronously, right now. So you can grab your database connection, you can get the user ID, you can do all your setup. All that context then gets closed over and captured by the inner function. And that inner function, that's what runs asynchronously when execute finally gets called. It's a brilliant separation of concerns. Okay, now, whenever we're playing with concurrency in Go, we have to talk about the dangers. And the big scary monster in the closet is the deadlock. So let's cause a little trouble on purpose and see how our pattern and Go itself holds up. So picture this. You're writing a test for your future. You set up a wait group, you call add1, and you tell your test to wait. You're expecting your async operation to call done when it's finished. But what if there's a bug? What if you just plain forgot to add that line of code? What happens when that call to done never, ever runs? Bam! This is what happens. The Go runtime is smart. It sees that your main test Go routine is stuck waiting forever, and it looks around and sees that no other Go routine can possibly wake it up. So instead of just hanging there silently forever, Go does you a favor. It panics with this beautiful, crystal clear error message. And you have to understand, this isn't a bug in Go. This is one of its greatest features. In so many other environments, a deadlock would just freeze your program. It would become unresponsive, and you'd be tearing your hair out trying to figure out why. Go's runtime is your safety net. It screams at you and tells you exactly what went wrong.
So how do we deal with this in our tests? Well, we fight concurrency with more concurrency. It's the Go way. We launch a second, tiny Go routine that does nothing but sleep for, say, 1 second, and then it closes a channel. Our main test now waits on 2 things. Either the wait group finishes properly, or our timeout channel closes. This simple trick transforms a terrifying, uncontrolled deadlock into a simple, predictable, and totally boring test failure. It's perfect.
Okay, so we've seen how it works, we've seen the pitfalls, and we've seen the elegant solutions. Now for the most important question of all. When should you actually reach for this pattern instead of just using a good old-fashioned channel? This right here is your decision-making cheat sheet. Just look at that first row. If the code that's calling your function needs the result right away to do its next piece of work, use a channel. It's the clear winner. But then look at the second row. For a true fire and forget operation, where the caller just needs to kick it off and then move on with its life, that is the absolute sweet spot for the future pattern. It's all about decoupling the caller from the outcome. And here are some classic real-world examples. Sending an audit log entry, firing off a welcome email to a new user, kicking off a process to warm up a cache in the background, sending an analytics event. These are all perfect fire and forget tasks. Your main application flow shouldn't have to stop and wait for them, but you still absolutely need to handle their success or failure gracefully somewhere else. And just as a final little piece of trivia, the name MaybeString wasn't chosen randomly. It's a little hat tip to the functional programming world, and specifically to Haskell's Maybe monad. It's a concept for representing a value that, well, might be there or it might be nothing. It's just a cool reminder that great programming ideas tend to pop up in lots of different languages. So that's the future pattern in Go. It is elegant, it has 0 dependencies, and it solves a really common concurrency problem in a clean way. It's all about separating the what from the how. So I'll leave you with one final question to think about. Look at the code you're working on right now. What's one fire and forget task in there that could be made simpler, clearer, and more robust by turning it into a future? Thanks for watching.